Before we move on from empirical probability, there's one other connection that we have between that and classical that's worth mentioning that's called the law of large numbers, which roughly says that for empirical probability type events that can be classically defined, as we take more data for our empirical probability, that value should get closer and closer to what the classical probability projects. It's not guaranteed to happen exactly that way, but it is a good rule of thumb to think that if I flip my coin, for example, an infinite number of times, those runs of tails will eventually get outweighed by runs of heads, and the probability of getting heads or tails will equalize towards that 50%. And we'll see something similar to this, about this idea of drawing larger samples to get more consistent results in Chapter 5 near the end when we talk about a thing called the central limit theorem. But anyway, the last type of probability that we'll get to here is what's called subjective probability, where subjective probability is the convenience sampling of probabilistic methods. It's essentially just guesswork. For subjective probability, you are maybe taking some sense from previous experience or getting an idea of what's going on, not using data, but just using intuition to say that a percentage is likely. This would be something like if a doctor suggests that you have a 50% chance of surviving a treatment, not based on looking at the number of patients they've treated, but just based on their rough recollection of how the surgery has gone in the past. Or if I was to just say without looking outside that there's a 50% chance that it's raining right now. It's not based on information, it's just a feeling, as it were. So, the last thing we're going to look at is a quick example for how to recognize the types of probability that we're working with. So here, we want to classify the following three statements as classical, empirical, or subjective probability, where we have the probability that you will get an A on your next test is 0.9. The probability B that a voter chosen at random will be younger than 35 years old is 0.3. And the probability of winning a 1,000 ticket raffle with one ticket is 1 over 1,000. Where in that first case, presumably you have some experience that you're drawing on based on previous exams, or maybe you've taken the class before, or you've taken similar classes before, but you probably don't actually have the exam in front of you. You're basing it on some information, but it's not really hard mathematical evidence, it's more a feeling. So, that first example there would be subjective probability, because it isn't based on hard evidence so much as it's based on a tendency you have a feeling about. Or maybe it's just a guess entirely. Don't know for sure, but without evidence, it's subjective. In the second case, it doesn't specify necessarily that you're drawing that from a survey, but the wording kind of plants in mind that that's where it comes from. That somewhere you have a survey of some number of people where 30% of them were younger than 35 years old. So because it seems like it should come from empirical results, this would be an example of empirical probability. And then for the third place, there, we're not told anything about a number of drawings, and we actually do have a fixed number of them with a fixed number of outcomes we're considering for our event, where it is 1 in 1,000. So that would be a theoretical, or if you prefer, as the book does, classical piece of probability. And the last thing we're going to look at for this section is a bit how we can describe events not happening. Because sometimes it's very easy to see how an event can happen, but other times it's very complicated. It can be useful to instead reframe things about the ways that other things can occur, around the ways that a complementary event can occur, that is.